Okay, now we look at the enthalpy change of solution. So the enthalpy change of solution is when one mole of a compound dissolves in water under standard conditions. Okay, so we've got potassium chloride, it dissolves, make potassium aqueous ions and chloride aqueous ions. Now something slightly different to that is the enthalpy change of hydration is when one mole of aqueous ions are formed from the gaseous ions under standard conditions. So we go from gaseous ions to aqueous ions like that. So this one is just looking at the measure of the attraction between the water and the ion. Okay, bigger attraction there is, the more exothermic the value would be there. Well, this one's always exothermic. This one could be exothermic or endothermic. So we can link them together. Okay, so potassium chloride, if it took in energy when it dissolved, the delta H salt will be endothermic. So this arrow is going up. Here we've got the solid potassium chloride, and then we've got the dissolved ions. Okay, how do we link those things together? Well, to make this dissolve, first you have to break up the lattice, and that's doing the opposite of what the lattice enthalpy is. So we break it up into the gaseous ions, and then we've got to hydrate each ion. So we hydrate the first one there's the chloride ion, and then we hydrate the potassium ion. Okay, so if we look at what the equation would be, if we want to work out what the lattice enthalpy would be, it would be the enthalpy of hydration of the chloride ions plus the enthalpy of hydration of the potassium ions minus the enthalpy of solution, because we're going against that one there. Okay, that would give us that value there. So it's a way of we can link up these three things: lattice, hydration, and solution, to work out one of the unknowns. Okay, if this was an exothermic reaction when it dissolved, that line there would be lower than this line, but it's the same principle. Okay.